right now.
Guys, give it up. Give it up for Matthew Fox. Sorry, there it is. Come on, come on, come on. Yes, yes, that is right. That's how we welcome people to the show.
I'm just realizing now my camera may or may not be mirrored the right way. Does that look like a little alpha fish symbol to you?
You're good.
I think you got it right, Matthew. Yeah, we're good to go. All right, let's put a minute on the clock for Matthew.
All right.
Let's count him in. All right. You ready, Matthew? Here we go. 1, 2, 3. Hit it, man.
Do it, Rockapella. Yeah. All right. Within science, we look at the relationship between different stuff doing different things. So we got things like alpha here, aka the fine structure constant. It's normally defined as elementary charge squared over 4 pi h bar c epsilon naught. Okay. That's not the point of what we're talking about today. What we're talking about today is the ability to reduce this, because you can take all this, and since it gives you a dimensionless number, you realize that's charge squared. So it's just charge, elementary charge over the Planck charge, all squared. Cool. So you take that same intuition and you look at the Higgs mass in relationship to the Planck mass. When you do it out under Wolfram alpha, you get 1.0 times 10 to the minus 17. That doesn't mean a dang thing to me. However, if you square it, all of a sudden this becomes 1.05 times 10 to the minus 34. Now, most folks, that shouldn't mean anything too. However, if you've done some physics with the extra 15 seconds I have here, this actually does come out suspiciously to the absolute magnitude of h bar. So the claim is the Higgs mass in relationship to this Planck mass squared is the absolute magnitude of h bar.
Yes, there it is, my friends. We have the first mathematician of the evening. We should all be very proud to welcome Matthew. Matt, how you doing, man? It's good to see you. I'm really glad you signed up tonight.
I'm doing all right. This is quite the vibe you guys got going on. It's an uplifting atmosphere. We're having some dance and everything. It's
man, you know, everything we do on the show is so darn serious. We decided we need a little steam valve on this operation, so trying to have a good time here.
Absolutely.
Man, you almost broke my brain with all those numbers.
I like that the gong is almost purely an academic exercise. Shilo's so sweet that he waits for everybody to finish and then he plays the gong.
Well, I want people to get through their point, but we'll hurry you along if we have to. All right, so yeah, this is in the theme of reducing things to simpler patterns than jump out to us originally. What
that was kind of the whole point. It's like you spit out this whole official definition there. It's like, okay, maybe you can parse that. I've thought about that, but then you look and you're like, well, this is a charge thing squared. This has got to be a charge thing squared. And then you can just simplify it to a much shorter notation communicating the same thing, which helps one to think about that. So all I did was really just kind of take that intuition, look at this, and then having gone down enough Wolfram holes, be like, oh, that's kind of weird. That looks a little familiar. And at first I kind of discounted it. I'm like, oh, it's only 3 significant digits and stuff. And then you get into the literature a little bit, and then you realize, wait a second, we've only accurately measured the Higgs to 3 significant digits, like 125, and then we got 2 digits of error in GeV. So I just thought it was interesting that if you did this, you can actually put this calculation to Wolfram alpha, and it evaluates as true, even though it's rounding. I submit a ticket error because I'm like, listen, we don't have the science to say that this is true. I just thought it was an interesting thing, so I'm writing a little paper on it. So I'm kind of in Michael's world right now.
Matt, by the way, for folks who don't know this, so Matthew lives at a Physics Monastery, which is...
I'm on the East Coast right now. I'm heading back in the next week or so to northern Utah. Yeah.
Can you tell people what a Physics Monastery is exactly?
That's a great question. It's a place to discuss scientific stuff and things like this. It's basically just right now we're currently self-supporting. We got a nice townhouse in northern Utah up in Logan there. If anybody happens to be going around, and feel free to strike up some correspondence. And as long as you're not too creepy and everything, maybe come by. We can talk some science stuff.
What does the day in the life of a physics monk look like?
We get up, we start doing breakfast. If somebody's already had an idea, we have a whiteboard readily present there.
What's for breakfast?
You just kind of write the ideas on. Dawn?
What's for breakfast?
We've done our legendary monastery breakfast burritos. I know Dan's had one before and everything. We made it in the mobile van and everything when we were down there in Austin. But just eggs, bacon, sausage, standard
Breakfast
American
of
folk
champions.
stuff.
Yes.
Okay, so you get fueled up and then just straight math.
Straight to the
Yeah,
whiteboard.
fully fueled up. We've gone through different eras where we'll go through like math videos. So sometimes we've gone through, I think, 280 or so of Professor Norman Wildberger's mathematics and the full intro, and then expand into the history of mathematics. And every time we'll come across something, it's like, well, that seems like some elementary algebra from 2,000 years ago. And we learn something. And very often there will be a relationship, because the relationship between different stuff and things, I believe Took was talking about, there are certain underlying patterns that you're going to notice again and again. And maybe it applies in many different situations. Maybe it only applies in some situations. So
I got a
that's the
question.
process of science.
Is the philosophy behind this project aspirational, that there is some simplified statement that can be made about the quantitative universe? Do you guys believe in the theory of everything? Is that the holy grail, or do you guys? It seems like this process of simplification is teleological to me. Like,
That
if
was
you're
such
able
a
to
complex
ultimately
sentence.
simplify things down, you might end up with one statement to describe it all. Do you guys subscribe to that kind of thing?
So like, are they looking for like a single equation?
That's a fantastic thing. I don't know. Ultimately, trying to satisfy one's own curiosity, as well as hoping that any knowledge that we can discover can help benefit the rest of our fellow creature and everything. I think that's kind of the goal. I'm not sure I answered your question.
Well, I'm curious. What's the practical application of this discovery?
That's a great question.
That's
I
going
don't
on the
know.
bingo card.
Again, this is private. I'm going with the stuff you can literally just put into a calculator. It will return true within some error bars there. Ultimately, we're going to need higher precision measurement for the Higgs to probably another 2 significant digits or so in order to see if there's some there, because right now we only have 3 significant digits. The next 2 are error. I'm just trying to leverage hbar, which we have defined at 10 significant digits, and the Planck mass, which is defined at 5, to try to predict a few more digits of the Higgs mass, if this were to hold.
Well, in engineering, we need at least 4. So you're not at engineering level yet.
Exactly. I'm not even good enough for engineering right now. So
I actually feel like I'm inside of a calculator right now. Send you the sound effect for that.
Okay, so sometimes it feels like math is just people finding operations that somebody else has done and then being like, I can do this operation in a slightly modified way. Is that what's happening here?
I mean, maybe it's because this is literally the same thing as this. That was the whole point. You've got a thing over a Planck thing squared. We got a thing over a Planck thing squared. So I'm just assuming that nature is simple, and maybe there is something to this as well. I originally first wrote it off because it was off by like 2.5, 3 sigma. So then I had to multiply it by a hyperbolic tetrahedron squared divided by that. But then I watched another YouTube science communicator, I think the bad boy of science, shout out to him, and he used a measurement, and I'm like, wait a second, the CMS measurements, this comes out to be 0.2 sigma away. So depending on the experiment you use, whether it's Atlas or CMS, is actually pretty solid agreement, or at least good enough for me to write a short little paper on. So,
Derek asks, what does it mean if it's true? What is that? What are the ramifications for the physics community?
This is the calculation, the interpretation from there. My best bet is, again, I'm not a quantum mechanic or mathematician by trade. I'm a dude on the internet that's interested, like a lot of folks out there. My thing is, okay, if the Higgs is a spin zero particle, maybe the mass of the Higgs is what it is in order for the elementary unit of action to act.
So it is less arbitrary than formerly understood to be.
I mean, it might solve a lot of things. I'm sure there's going to be some mathematical set or group or rotation that you would need to elaborate on in order to have this come within the standard model or some other iteration of whatever one is trying to put together. So ultimately, I don't know.
I'll take that.
Are there other patterns in nature that are thing over Planck thing squared that give you meaningful values?
I'm pretty sure there's a number of different combinations, because if one of the things that I've noticed and I learned from Thad is you can break down the dimensions that we measure into 5: time, space, charge, mass, and temperature. That's the only reason I was able to do this. I took Thad's method and I'm like, well, you got 5 dimensions of things. Pick one and look at the different relations. I'm pretty sure there are, but I don't hold me to that.
Interesting.
All right, Matthew. I think we should move it along so we can get some more people in here, man. But
right on.
You did it, dude. You came on. You participated in the historic first event. Everybody, give him a hand. Give him a hand. Thank you, Matthew. And on deck.
Oh wait, hold on.
Sorry, Doug's got one more. No, what's up?
No.
Where
Go
can
ahead.
people find Matthew?
Yeah. Where can people follow your work up?
On the YouTubes at the Memes of Destruction, or on the Twitters at Meme Destruction.
There it is.
Excellent.
All right, guys.
All right,
One more
thank you
time
so much,
for Matthew.
Matthew.
Thank you, guys. Yes.